Welcome. In this video we're going to talk about projectiles at angles. And if you remember in the last couple of videos we've been talking about projectile motion, and we've talked about projectiles in free fall and projectiles that are launched horizontally. In this video we're going to take it one step farther and we're going to launch our projectiles at an angle and answer the same type of questions. So let's get started. It says that in this question it says you kick a soccer ball at an angle of 30 degrees with a velocity of 14 meters per second. How long will the ball be in the air, and how far will the ball travel horizontally before hitting the ground? And we can solve these problems in the same kind of order that we've been solving projectile motion problems in the last couple of videos. I think the best place to start is always to draw a picture of what's going on. And so I'm going to draw a picture of the soccer ball. Okay, and we're kicking it at an angle of 30 degrees. So let me see if I can draw an angle of 30 degrees, and we're kicking it at a velocity of 14 meters per second. And so I'm going to draw the triangle here and divide. Since we're kicking it at an angle, I'm going to divide its velocity into its horizontal and vertical components. And so I'm going to draw the ground here at a dotted line and the vertical component here, and this would make a right triangle. And so now we can break this up into its horizontal velocity, which I'm going to call v sub x, because it's on the x-axis. And I'm going to call the vertical velocity, that component, v sub y, because it's more vertical on the y-axis. And I'm going to go ahead and find the initial horizontal and vertical velocities of this soccer ball, and just break up its initial velocity into its components here using trig. We know that this angle you kicked it at was 30 degrees, and so we can use our trig functions to solve for v sub x and v sub y. I'm going to do v sub x first. If we look here, it's the side of this right triangle that's adjacent to your angle, and we've got the hypotenuse, and so that will be cosine. So cosine of 30 is going to be equal to adjacent, which is v sub x, divided by the hypotenuse, which is 14. And so if we times this equation by on both sides by 14, we can isolate v sub x. And so v sub x is going to be equal to 14 cosine of 30. Let me go ahead and solve for that right now. So 14 times the cosine of 30 is equal to 12.1, and so v sub x is equal to 12.1 meters per second. And we can put that in on our triangle, 12.1 meters per second. And now let's solve for v sub y. If we look at it, it's the v sub y is the side opposite of our angle, and we have the hypotenuse. So opposite over hypotenuse is sine. So I'm going to do sine of 30 is equal to the opposite, which is v sub y, velocity in the y direction, divided by the hypotenuse, which is 14. And so again, if we times this equation by 14 on both sides, we can isolate v sub y. And so v sub y is equal to 14 sine of 30. So let me do that on my calculator. 14 sine of 30 is equal to exactly 7.0. So v sub y is equal to 7.0 meters per second. And put that over here, 7.0 meters per second. Okay, and so what we've done so far is we've taken its initial velocity and broken it into its horizontal and vertical components, which will be important for solving this problem. And just like with the other problems, with projectiles at angles, you always want to break it up into its horizontal. So I'm going to write that. The horizontal and vertical components. And so we know horizontally that we can use equation number 1, which says that displacement horizontal is equal to the horizontal velocity times the time that the ball is in the air, or the projectile, whatever it is. And so we do know the velocity here is going to be the horizontal velocity. So displacement of this projectile horizontally is equal to 12.1 meters per second times time. And we still don't know time. And so if you look here at the horizontal equation, we have an equation, but we have two unknowns. So there's no way we can solve for time in this horizontal direction. We're going to have to solve for time vertically. And so let's move over here to our vertical direction. We know that in the initial velocity in the vertical direction was equal to 7.0 meters per second. So 7.0 meters per second. The final velocity, it didn't tell us in the problem. Time initial, I'm just listing everything that we know in the vertical direction. Time initial we always call 0 seconds. And time final is really what we're looking for here. And so we really want to find time final. Some other things that we know in the vertical direction are its displacement, the amount that it was displaced vertically. We're going to call that displacement initial when you first kicked the ball. We're going to call that point 0 meters. So it's right on the ground is 0 meters. And we know that this ball is going to go up and then it's going to come back down to the ground. So we also know displacement final is going to be 0 meters because the ball is coming right back down to the same position on the ground, vertically speaking. And we also know acceleration in the vertical direction is always a negative 9.8 meters per second squared. And so now that we have everything listed that was given, we can pick an equation that helps us solve for time. We know we can't use equation number 1 in the vertical direction because our velocity is not constant. Equation number 2 doesn't have a displacement, and we also don't know final velocity, so we can't use equation number 2. Equation number 3 has the final velocity, and we don't know that, and we don't know time. So we're going to use equation number 4 again. That's kind of our go-to equation. And so I'm going to rewrite that equation number 4. So displacement vertically is equal to velocity initial times time plus 1/2 acceleration times time squared. And we know that our displacement vertically was 0. So I'm just going to plug a 0 in for that d for displacement. Our initial velocity vertically was 7 meters per second. So 7 times t, which we don't know. So that's 7t plus 1/2. A is a negative 9.8, so a negative 9.8, and times t squared. We don't know time. And so if I simplify this equation as much as I can, we get 0 is equal to 7t, and 1/2 of negative 9.8 is a minus 4.9 t squared. And what I always like to do at this point is try to get this term to be positive. So I'm going to move that over to the other side, and I'm also going to move this 7t over to the other side. And so adding a negative 4.9 t squared to each side, I get over on this side it would be positive 4.9. So 4.9 t squared minus 7t is equal to 0. So all I did was move both of these terms to the other side right there. And now we get this equation, and we have two t's, and we have a t squared and a t as a minus 7t here. What I like to do is the easiest thing to do at this point is to factor a t out. So I'm going to pull a t out, and that leaves me with 4.9. So 4.9t minus 7, and all of this is still equal to 0. Now if I divide both sides by t, we know that t is equal to 0 because 0 divided by t is 0. And we know that can't be the case because time has to be something. There's going to be some time value while the ball is in the air. And so let's really focus on this term inside. and set that equal to 0. And so 4.9 t, and I'm going to move the 7 over to the other side by adding 7 to both sides. And so is equal to 7. And now it's just a simple equation. We divide each side by 4.9. So 7 divided by 4.9. On this side, the 4.9 will cancel out. And so t is equal to 7 divided by 4.9. And it's coming out that t is equal to 1.43 seconds. And so that's the answer to the first question that this question was asking. How long will the ball be in the air? It will be in the air for 1.43 seconds. And now let's move to the second part where it says how far will the ball travel horizontally before hitting the ground? And now we come back to this horizontal equation here, and we can plug in the t value. So we know that displacement is equal to the horizontal velocity, which was 12.1 meters per second. And we're going to times that by the time, which was 1.43 seconds. And you'll notice here that our seconds are going to cancel out, and our displacement is left in something measuring in meters. And so 12.1 times 1.43 is equal to, the displacement is equal to 17.3 meters. And so that's the answer to how far the ball will go horizontally. So it's pretty cool. We can figure out a lot about projectiles. We can figure out how long they're in the air, how far they're going to travel horizontally, which is also called its range. So this is also known as the range of the projectile. And so yeah, we can do a lot of cool things with these physics equations. What I've got for you now is a couple of video physics assignments or video physics questions that will go over some of these same principles. Just I'll change the numbers up a little bit so that you still know the process. And so yeah, there's two questions that will follow. I'll scroll through them slowly so that you can get a chance to write them down, and your assignment will be to answer those two questions and then turn it in. If you get confused at all, try going back through the video and watching it one more time. If you still have some questions come in, I'm available anytime. I'll help you, and we'll learn it together. So good luck.